Okay, so now that we have set up the data the way we want it, so let's do a data partition, and let's do 40 training, 40 validation, and 20 for test. And neural networks is notorious for overfitting. So if you throw in enough variables, okay, and there is no variable selection, like in regression you have stepwise, there is nothing like stepwise here in neural networks. So it'll use the entire data set and try to fit a model. So you want to check with data that is not used in modeling to see how good the model is with new data. So that's why I'm leaving, we'll check validation. So validation set will be used for selecting the model, right? So you fit the model, and then you use the validation to make adjustments. So we need a third set that is completely new, not used in any way in the modeling. So that's what this is going to be. And if it's good, if the model is not overfitting, then it will have a similar kind of misclassification rate or error rate for the test data like it is in the validation data. All right, so now let us do a neural network. So that's that one. And I'm going to use initially, I'm going to use only some of the variables that are listed in the chapter in your textbook, okay, and then see what happens. Okay, sometimes you may have to do some trial and error before we get to a good model. So let's use the same list of variables that they have used, which is okay, so we have alcohol. All right, so it's in page 262. So edit variables. Okay, now I'm going to highlight the entire list and change use to no. Okay. And then we will go and select the ones that we want to use. So maximum severity, that's our target. So make that into a yes for use. We'll use alcohol, profile IR, surface condition. So we're going to use the revised surface condition, vehicles involved. So those are the variables that we're going to use. Okay. Then there are a couple of things here that we can look at. Network and optimization. These are the two, and we're going to use the default, because default is one hidden layer, and then look at so here the multi-layer perceptron. That's what we discussed. So direct connection means, will you have connections directly going from input straight to the output without making any connection to the hidden layer? In addition to the connection to the hidden layer, are you going to have direct connections from input to output? So that's what that is, and we don't want that. The number of hidden units, that is, it's one layer with 3 hidden units. Okay, randomized distribution, this is for weights, the initial weights that are assigned at random, so you can use normal distribution for that. And you can change the center and the randomized scale too. So this is like minus 0.1 to plus 0.1, with 0 being at the center. If you want to change that, you can change that, but we are going to do that. Input standardization, here we're going to change that to range. Range changes Okay, remember range is, your conversion is from 0 to 1. So you take a value minus the minimum of the column, the smallest value for the variable, divided by the range, maximum minus minimum. So that will convert the original column to a set of values which is between 0 and 1. Okay. All right. So the rest of them, are we going to keep it as such? The weight decay, this is different from the learning rate. Weight decay, it controls, the larger the value, the more the weight, the magnitude of weight change would be more. So, but again, the default is 0, so we'll keep it at 0. And the learning rate is in optimization, and the learning rate you can change only by setting this to backprop, okay, and then we can change the learning rate. Otherwise, the learning rate is, I think it's 0.1. Okay. All right. So those are the only two things that we have to look at. Okay, so now you run. Okay, so it takes a little bit of time. And how many observations we have here? So it's about 42,000 records, which is comparatively a small data set. So it takes a bit of time. Of course, this is just a PC. But if you run with and I've seen SAS programs running with like 14 million records in just seconds like that. So, all right. So here we have misclassification rate, 45%, 45%, 45%. That's really high, isn't it? 45% misclassification rate. So let's look at the output and then see what's going on. So if you go down to how the classifications are done, so we have 0, 1, 2, so this is the validate. Well, here is all doing the same thing, I guess. So a bunch of them are getting classified as 0, and then another bunch classified as 1, and there are too many false classifications. So this is not really very good. You can try a different model selection criterion, because we did not specify profit and loss, so a misclassification rate was probably used. So we can change it to average error, which will be like y minus y hat. So y is either 0 or 1, or here it will be 0, 1 or 2, and then you will have a probability for each of them. So if you change it to average error and run, okay, let's look at the results. And the misclassification rates are again same thing. I bet the classifications were exactly like what we saw before. So a bunch of zeros, a bunch of ones. So none of the records are getting classified as 2. They're all getting classified as 0 or 1. So the fatalities, the maximum, the methodology is not predicting any record as belonging to the maximum severity of 3, which is a maximum severity of 2, which is injuries with fatalities. And we have, we can look at how many, so let's look at the results again. So how many fatalities are there, injuries with fatalities? So the target, okay, so here we have 78 and 108. So the total is 186, okay, out of 40,000. Well, actually this is validate. So 40% of 40,000 is 16,000 records. Only just 1% is fatality. So what does that tell you? So this is a rare case event. rare event case. So maybe we should try to oversample the rare event, so to have more of that, so we will be able to develop a model that will predict event class is equal to 2. Okay, so let's look at how to do that.